Hello friends, we are still on the resolution of vectors. We want to convert from magnitude bearing form to component form. Now if we have a vector OP with the coordinates xy, in magnitude bearing form, this vector will be given by r theta, where r is the magnitude of the vector and theta is the bearing of the vector. R will be given by the length of the vector, and that will be the length of the hypotenuse here, and theta will be the angle measured from the north in the clockwise direction. We've already established that alpha is the angle the vector makes with the x-axis. So this is our alpha. Now if P has the coordinates xy, then when we trace down to the x-axis, the length will be x, and then tracing to the y-axis will give us a length of y. It will correspond with y up here, and x will correspond with x-axis up here, forming a right angle triangle up here and down here. So our first right angle triangle, we can have OPQ. Let's call this point Q. And then our second right angle triangle, OPR. Good. Now, if we consider the right angle triangle, OPQ. Theta is the angle in question. And so x becomes our opposite, y becomes our adjacent, and r becomes our hypotenuse. So if we are looking for cos theta, we can use sine. Sine theta, which is opposite over hypotenuse, will give us x over r. We can also use cos theta, and we have the adjacent y over r. So if we make x the subject, we can cross multiply, and we'll have x is equal to r sine theta. And again, we can cross multiply our second equation, and we'll have y is equal to r cos theta. So very simple and straightforward. Considering the triangle OPQ, if we are to convert from P r theta, we are going to have x, y being equal to r sine theta over and r cos theta. R sine theta, r cos theta. Now, what if we consider triangle, right angle triangle OPR? Right angle triangle OPR has the angle alpha in question. Now, in this case, y is our opposite, x is our adjacent, and r is our hypotenuse. And so, we are going to have cos alpha will give us x over r, which is the adjacent over r, the hypotenuse. And so x will be equal to r cos alpha. And then sine alpha will be y over r, opposite over hypotenuse. And so our y will be equal to r sine alpha. And so to convert with using alpha, we are going to have r cos alpha, r sine alpha. So we have two formulas, one using the bearing, one using the angle the vector makes with the x-axis.